All right, guys, you want a little review here, or a little bit of work here, as I adjust my screen there. So here we go. I'll switch over to blue. Multiplying monomials most of the time here. That's kind of what's going on here, and then dividing on the back. So first up from the other day, we have a bracket here and a number in front, and this really means, let's go over some things so we're not confused. This means 3 times all of this, okay? So when you have a number beside a letter here, a variable, that means 6 times x cubed. And if you have a number here like 3, or in front of a bracket, that means 3 times whatever's in the bracket. And it means 3 times everything in the bracket. So what you'll do here is it'll be 3 times x and 3 times 2 distributed property, right? So then that's 3x. 3 times x is just 3x, and 3 times 2 is 6. Okay, so that's how we do that. And now let's look at what happens when what's in front, what we're multiplying, or both things we're multiplying have a variable. Okay, so if you have here, for example, 6x cubed times 2x to the fourth. So what's up with that is, well, we know the exponent rules. So my whole rule is this, and I've said it before, and I'll say it again. It's numbers times numbers. So numbers times numbers. And that's what that says. And letters times letters. Okay? Multiply your constants or your coefficients by each other, and multiply your variables by each other. So 6 times 2, so you go 6 times 2, or 6.2, or whatever however you want to put that, is part of that, and then you have x cubed and x to the fourth, okay, and they're multiplying. So you don't need to add this step in here after this when you do your own work, but it's 6 times 2, and we know that's 12, and then exponent rules say when you multiply like bases, you can simply write the base again, and then with the exponent, it's 3 and 4, you add them together. So multiplying is adding. Why is that true? X cubed is this, x to the fourth is this, for them. Remove these brackets in here, and then you have x times x times x times x times x times x times x, x to the 7. Okay, so multiply the letters by each other, and then multiply multiply the numbers by each other, then multiply the letters by each other, and use the proper exponent rules to help you out. Okay, so here I have -2 and 3. That is -6. I'm just showing you here what happens with a negative. And k's, how many total? 6 and 2, 8. Okay, here a minus and a negative and a negative turns into a positive. You can write that plus, or you can just have it disappear. It's fine. I'll just write it for fun, I guess. And let's look at this. Okay, what's going on here? This is a -1. So -1 and -5, multiply them together, get +5. Also, just k by itself is really k to the 1, right? There's 1k here, there's 4k's there, so in total we have 5k's. Okay, these 5's being the same, just a coincidence, but 1 and 4. So what I wanted to show you here is a couple things. Any coefficient missing, the constant here is missing, the exponent is missing. Both of these are assumed to be 1. Okay, let's move on to division. This here is 9x to the 6 over 3x to the 4. That's the same as saying 9x to the 6 divided by 3x to the 4. It's nicer, I think, when you look at it as a fraction, and we look at it like this. I think it works better with you. At least it makes more sense for me. And actually, tell you the truth, when you do a lot of grade 9 and grade 10 and mostly grade 11 dividing and multiplying, what you'll do is you'll treat them like this as opposed to like this. And same rule applies with multiplying: letters by letters, numbers by letters, or sorry, letters by letters, numbers by numbers, by numbers, letters by letters. Okay, so 9 divided by 3 is 3. Okay, so 9 divided by 3 is 3. Then when we divide, remember the rule with division is, well, let's come up with the rule here real quick. I have 6 x's on top, I have 4 x's on the bottom. These guys cancel each other out. That cancels out, 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 and I'm left with 2, right? So I canceled out 4 from the top, 4 from the bottom. I have 2. And how do you get 2 from 6 and 4? You subtract them. Okay, so when you divide, you subtract the exponent number. So 6 and 4, 6 subtract 4 is 2. Okay, just wanted to show you this also. Negative 27 divided by 3 is -9. And then this, I have G1. Okay, that's a G. It doesn't matter what it is. G's or K's or P's or Y's, whatever. 4 and 3. 4 and subtract 3 is 1. You would also see it like this. that's actually probably preferred. If you write this, this is fine. The reason I'm showing this is if you see this on a test as an answer, or you see this in a textbook as an answer, I should say, notice that this is the same as this. Okay, don't get thrown off by that. Okay, so 9g is the same. Sorry, negative 9g is the same as negative 9g to the 1. What happens if the letters are different? So if I have this, okay, if I had, I don't know what this is, let's go 18 and 9. Sorry, that's x, so let's start again. 18x cubed divided by 9y squared. Still, 18 divided by 9 is 2, and then now I have x and y. You can't do anything with that. So this would just remain like this. You cannot divide x's by y's or y's by x's. You can, but they don't simplify any further. Okay, that's it. Hopefully that makes sense. Any questions, fire me an email. Thank you.